Welcome back. In this video, we're going to solve rational or fractional inequalities. And again, I'll do the sample here on the left and have instructions on the right-hand side, and we'll try and follow along with those and work in conjunction with that. So we want to solve and graph the solution set of x plus 2 over x minus 1 is less than or equal to 5. So our process, we want to write the inequality so that 0 is on one side. Okay, and we want to write the opposite side as a single term with a common denominator. So we'll just go ahead and write this, follow step by step here. So we subtract 5 from both sides, and we get x plus 2 over x minus 1 minus 5 is less than or equal to 0. Now we need a common denominator, so our common denominator is x minus 1, so we have to multiply the top and bottom of the negative 5 by x minus 1, so we're left with x plus 2 minus 5 times x minus 1 all over our common denominator of x minus 1 is less than or equal to 0. I'm going to distribute my negative 5 and simplify. So in doing so, we'll simplify to negative 4x plus 7 all over x minus 1 is less than or equal to 0. Now our third step here, we want to determine the values that make the numerator and the denominator equal to 0. So the numerator equal to 0, well, that means our fraction is 0. And if the denominator is equal to 0, that's undefined. Our fraction becomes undefined. These are going to be our critical points. So in doing so, real quick, negative 4x plus 7 equals 0. So that would make our fraction 0. We get x equals, it's going to be negative 7 over negative 4, or 7/4. So that's one of our critical points. And in the denominator, x minus 1 equals 0, so x equals 1. That's going to be the value that makes that fraction undefined. Okay, that's our other critical point. So we'll go ahead and put our number line out here. Our critical points are 1 and 7/4, or 1 and 3/4. I have these written in the right place. And so now we have three different regions. We have all the numbers to the left of 1 or less than 1. We have numbers between 1 and 7/4. And we have numbers greater than 7/4. So we're going to have to check numbers in each of these regions to see if they satisfy our original inequality. Okay? Do we get a true or false solution? If it's true, then all the values in that region satisfy the inequality. Okay, so if I test 0 here, that works for everything in that region. Okay, so let's go ahead and start doing that. We're going to have to pick 3 test points and see what works. So I'm going to test 0 here, see what happens. So if I test 0, and for x in my original equation, okay, x plus 2 over x minus 1 is less than 5. So less than or equal to 5, I think that was. So if I put 0 in, I'm just going to get 2 over negative 1 is less than or equal to 5, and that I get negative 2 is less than or equal to 5, and so that is true. That's going to work. And since this is inclusive, right, our critical points are going to be inclusive, so everything in that region satisfies the inequality. Now I have to test something between 1 and 7/4. I'm going to test 3 halves, or 1.5. So if I test 3 halves, I will get 3 halves plus 2 or 4 halves over 3 halves minus 1 is less than or equal to 5, what is that, 7 halves all over 1/2 is less than or equal to 5. So I get 7 is less than or equal to 5. Well, that is a false statement, so I'm not going to graph anything in that particular region. And then for 7/4, I need anything greater than 7/4, 1 3/4, so I could test something like 2. Let's see here. So if we test 2, so we get 2, and putting it in our equation, we get 2 plus 2 is 4 over 1 is less than or equal to 5. That is a true statement. 4 is less than or equal to 5. So that means everything in this region, inclusive, is going to satisfy. So there's our graph. And then our answer writing in interval notation is going to be everything from -infinity all the way to 1, inclusive, in union with the values of 7/4 all the way to +infinity. And we're inclusive of the 7/4. So that's our process for solving rational inequalities, and you'll get some more practice on that when I see you in class.